So I think in order to understand definitions, we should take a look at just set and set delayed. That's really those are the two primary ways to understand this thing. So if we do a equals 2, let's say, right? What we should have here for a is equal to 2 is that whenever a appears in the computation, it's already 2. So a plus 3 is 5. Big surprise, right? 2 plus 3 is 5. And the reason is if we ask about a, we see that a is equal to 2. That's just a global definition for a. That's what a is. This, when we use equals, is called set. And that just assigns a value to a symbol. Whenever the symbol is seen in a subsequent computation, it will be replaced by whatever value you've given it by its definition. The reason I had written that stuff above about like plus and set and so on is just we talk in Wolfram language a lot about shorthands because underneath there's a tree structure that everything is built on. So when we say a is equal to 2, the reason that we're talking about set in this context is because underneath this is the same as set a to 2. So the full form, so to speak, of the equal sign in Wolfram language is set. It's not really a mathematical equals in that sense. It's a computer sciencey. We are setting the thing on the left equal to the thing on the right definitionally. Suppose I use set, that is the equal sign, to set b equal to a random real number between 0 and 1. If I then evaluate b here, notice that it's this. Now Meech is doing the thing that I mentioned where he tries to stand on the trackpad just a little bit. There we go. I rotated him. We can see that we have 0.226705, right? And now if I add 1 to b, I get 1.2267. Whenever I look at b, it's just 0.226705. That's just what b is. So set will evaluate the right-hand side of your definition immediately. And whatever the resultant value is at that very moment, that's the value that's assigned, and that's it forever. So no matter what I do with b, it is what it is. You know, it's always, as you see above, this number. Set delayed, which is the full form of colon equals, which is how you might often see people defining functions in Wolfram language. It's used for delayed assignments. And the difference is that the right-hand side is not evaluated until the left-hand side is invoked in some computation. So note above, we said that b is equal to random real 0, 1, and we set it. Here, if we have the exact same code, we just say that c is colon equal to, but the right-hand side is exactly the same. Let's have a look. If I invoke c in some computation, there it's 0.326187. Here, it's a different number. Here, it's a different number again. And the reason for that is that if I ask about c, the right-hand side, well, we delayed the evaluation, right? We use set delayed, and so the evaluation was delayed. C's definition is just that it's a random real between 0 and 1. We're not actually going to evaluate that until we use it in a computation. And to really drive this point home, I think a graphical example is good. So take one-time random polygon here. I said it has a random color, regular polygon, random integer, and it's going to have a random number of sides between 3 and 16. If I ask about it, RGB color, it's got a particular color and it has 15 sides. And indeed, if I do this, and if I keep rerunning it, or if I try to make copies of it, say I make a constant array where I have 5 copies of it, it's always the same thing. Now, if I take that exact same code that I had on the right-hand side, and the only difference is that I use a colon equals here, I'm going to, very leadingly call this always new random polygon. Watch what happens when I run this. I get this. And if I run it again, I get that. And if I run it again, and again, and again, and again, I always get something new, a new color, a new number of sides, because it is indeed an always new random polygon, because I held the evaluation of the right-hand side until computation time. Indeed, if I look here at always new random polygon, we can see that the random color is just set to be random color. We haven't evaluated it. And the random number of sides is just a random integer between 3 and 16 inclusive, versus up here where those things were decided because we didn't delay it. We evaluated the right-hand side immediately. So that's the difference there.